Welcome back to another Unity FPS tutorial. In the last video we made our player controller, and today we're going to be adding crouching and footsteps, as well as fixing a few problems that currently exist in the player controller. Let's get started. Firstly, you might notice the SFX folder. This folder will contain our sound effects for the project. To get the sounds that I'm using currently, there will be a download link in the description for the Unity package, which contains the footstep sounds I will be using for this specific tutorial. Download it and import it into the project. Now before we do anything, I want our plane just to be a little bit bigger. So I'm going to scale it by 15 on the X and 15 on the Z. And also, just so we can see everything clearly, I'm going to create a new material for our player. So let's create a folder where we can store all our materials. And let's create a new material. Let's do it for our ground actually, so I'll call it mat_ground, and then I'm gonna pick red, and I'll just do it a full red, and then I'll drag it on, and now it's easier to see our player on the ground. And then now I'm gonna create a few cubes just so when we're rotating it's obvious where we're rotating. So I'm gonna create a cube, and I'm going to reset its transform so it's in the origin. I'm going to set its Y to 0.6, and then I'm going to make it a child of the plane, and then I'm going to set its Z to 0.5, and then I'm just going to duplicate this cube and then just set the different positions, and I'll set this to -0.5. See if that, and then I'll just do that one more time, and I'll set that to 0. And then I think we can do one more. Oops, we can do one more cube, and then we'll do -0.25, just so it's all nice and even. And then we'll duplicate this one more time just so there's something on this side, and I'll just do 0.5. And there. So now we have different cubes around us. So if we look around, we can see all these different cubes, and it's easier to see what direction we're looking. Now, if you have been playing around with moving our player, you might have noticed a problem when moving it in the diagonal direction. But if you haven't, I'm going to demonstrate it now. Because when we move in our cardinal directions, you'll notice that our speed is always the same. But if we move in a diagonal direction, you'll notice that our speed is greater than if we're moving in a cardinal direction. And we don't want that. We want our speed to be the same as when we're moving in any direction. So let's go and open up our script and fix it. Once you have opened up the script, let's look at our move variable. This stores our velocity vector. Note that speed and velocity are not the same thing. Velocity has both a magnitude and a direction, while speed only has a magnitude. Now, when the player moves in the cardinal directions, the speed of the player is 1. However, when we move the player in a diagonal direction, the speed is greater than 1. So, what we need to do is create a velocity vector that's magnitude. It never exceeds the value of 1, because the magnitude of a velocity vector is going to be the speed, since speed is just magnitude. So, what we can do is we can create a method called vector3 and then get velocity, and this method is going to return a vector3. And then first what we can actually do is we can take this code and put it in this method. So we just create our velocity all in one method just to keep our code more organized. Then what we have to do is make sure this vector's magnitude is never greater than 1. So what we can do is we can return we can use a method called vector3.clampMagnitude, and then we can type move. We can pass in our move vector, which is our current velocity, and then we can say that we don't want it to be longer than 1f, so that's the max length of our vector, or the max magnitude I should say. And then we can just pass this function into our controller.move method, and then let's test it out. Now if we move forward and diagonal, and let's move in our cardinal directions, you'll notice it's all the same. So we have successfully fixed that problem. Now that that's fixed, let's implement crouching. Open up the player movement script. Before we do anything related to crouching, let's create a variable to represent if the player is grounded at any time, so we don't have to call controller.isGrounded. And then let's replace the variable in update that we created with our instance variable, so it updates, so we don't have to create a new variable. Next, let's create a variable for if the player is crouching. This will come in handy later. Next, let's create a method called checkCrouch. So we can do that, and we can make it private since we don't need, no other script needs it. And then we want to first check if we are hitting the left control key. So we can just do, input.getKey, not get key down, and then we can do keycode.left control, and then we'll also have an else because we have to handle if the player isn't crouching. So first what we can do is we can check if the player is grounded, because we don't want to crouch in the air, and if we're not already crouching, then what we will do is there are three things we want to do. We want to reduce the speed, we want to reduce the jump, and we want to reduce our Y scale. So I'm just going to divide those 3 by 2. However, you can do as you want, or whatever you want. And then at the end, make sure you set is crouching to true. And then in our else statement, we want to first check if we are crouching, because if we are not crouching and we're not hitting the key down, we don't have to do anything. Then what we can do is we can just copy all this code, because we're just gonna have to change a few things, and then we're just gonna instead multiply, so we actually reset to our original values. And then at the end, we want to set this to false. Lastly, let's call this method right after we call controller.move, just in our update function. And then hop back into Unity. Now let's hit play, and you should be able to crouch, and you should be slower, and your jump height should be lower as well, and it should reset once you uncrouch. Now that we have finished crouching, it's time to implement player footsteps. So let's open up our player movement script. First, what we're gonna need to store all the footstep sounds that can be played. So we'll have a serialized field for that, and then we'll have a private audio clip array of playable footstep sounds. And then next, what we're gonna need a variable to represent the amount of distance the player will have to travel before a footstep will be played. So we will say a private float, and then we'll have footstep distance. And then lastly, second to last, we're gonna need to have an audio source to actually play our audio clips. So, and then we can just, in the start method, we can set audio source equal to get component audio source. Finally, we're gonna have to store the last position a footstep was played, so we can keep comparing. So we can just simply have a vector3, and we'll say last footstep position, and then in our start method we'll set that to our current position. So the footsteps start from our current position. So those are all the variables we're gonna need. So now let's create our first method. So our first method is gonna be called footstep, and all it's gonna do is play a footstep sound. So we'll call audio source.play one shot, and this method, it takes in an audio clip and just plays it. And then what we'll pass in, we create an array of playable footstep sounds, and we want a random one, so we can just do that. And then we can just use random.range of 0 to playable footstep sounds, and then we'll just use the length, and it's exclusive, so excuse me. So since it's exclusive, it'll be from 0 to playable footsteps length -1, which is in bounds of the array. And then we want to reset our position again to our current position, or our footstep position rather. We want to reset that to our current position so that we're starting there. Next time we're checking if we want to play a footstep. Speaking of that, let's do that now. So our next method is going to be called check footstep, and this is going to check if we're going to play a footstep. So first, oops, I can't spell that. So first, what we're going to want to do is, if we're crouching, we obviously don't want to play a footstep. So we'll just check if we're crouching using that variable we created. We'll return out of the method, and then we can before we check the distance, we're going to just check if we're grounded, because if we're in the air and we move a little bit in the air, we don't want a footstep to be played. So we'll check that, and then we'll use a function called vector3.distance, which returns the distance between two vector3s. And then we're going to give our last footstep position and then our transform.position. So we'll get the distance between the last position we played a footstep at and our current position, and we'll check if that's greater or equal to our footstep distance. And if it is, we'll call our footstep method, which plays a sound for us, which we just created. Then we want to call this method in our update right after check crouch. So that's all for moving on the ground, but in the air, if we jump and land, we're going to want to play a footstep as well. So how can we do that? Well, what we can do, we can have a variable, private bool, and we're gonna just call it play footstep on land. Now, how are we gonna handle this? Well, in this code, or in this player movement script, this variable can be changed, and then at any time. So what we're going to do is, if it's by default, it's going to be false, but if it's changed to true, what we'll do is we will call the footstep method, and then we'll set this variable to false. Or, oops, that wrong variable. And then, where do we want to set it to true? Well, we want to set it to true when we jump, because we're going to be above the air. So a perfect place to set it to true would be right here. So I'm just going to do that now. And that's it for the script, and let's recompile and head into Unity. So before we actually test it, we have to do a few things here. So first, let's set our footstep distance, and when I was testing it earlier, 2.4 worked pretty well, so I'm just going to go with that. However, feel free to play around with it. And then we're going to have to add all these footstep sounds, and the sounds are in this folder called footsteps, which we imported earlier. So I'm going to import them now. And then after we import them, or not import them, sorry, or put them in our script. I don't know how to describe it, but yeah, you get the idea. We're gonna have an audio source right here, and we need this because we're referencing an audio source right in this our start method, because we need to actually play sounds that way. So now we've done everything there, let's test it out. And it seems to be working on here when we're moving on land. Let's test it. Let's test our jump. And if we jump, we play a sound, and land, we play a sound. And if we're crouching, we don't play a sound, but we do if we jump, and usually we want that, or most games have that, and we'll have it in this game. So now we've excuse me. Now we've finished our footsteps, and that's it for this tutorial. So I will see you in the next one. Peace.